Hi physics students! As promised, here's a tutorial on doing your practice problems from Unit 2, Lesson 4. And this is Part 1. The practice problems that are on my Google site are divided into two sections. These are the same practice problems that are listed in your Connexus lesson. I've just typed them up for you. Okay, our first question says, a roller coaster moves 83 meters horizontally, and if you're using the textbook version, it's 85. I typed it differently in the one that's on my Google site, so your answer will be a little different, but it's done exactly the same way. Then this roller coaster travels 45 meters at an angle of 30 degrees above the horizontal. What is its displacement from its starting point? Draw the vectors tip to tail and use the Pythagorean theorem. All right, so we begin these kinds of problems by making a drawing. So let's make our drawing here. We've got 83 and it's into the horizontal. It doesn't tell us which direction, so we're just going to pick this direction. Then we've got another vector that comes off at 45 meters. Now, in order to solve one of these problems, let's put our resultant in here. Here's our resultant. So we're trying to find the length of this. That would be our magnitude and the direction of this vector here. In order to solve these kinds of problems, we have to have a right triangle, and you can see that at this point we don't have one. But we can draw a right triangle kind of around our resultant, and that will allow us to solve this problem. So if we come up from here from the top, drop an imaginary line down to the horizontal, and come from the horizontal over, you'll see that we've formed a right triangle there, even though that's not actually part of our problem. We do know that this angle right here is 30 degrees because they told us that this vector that's 45 meters is at 30 degrees above the horizontal. Given these pieces of information, we can use trigonometry to find the missing sides of this triangle and solve for our resultant. So let's begin by finding this vertical side that's the opposite because it's across from the 30 degrees, and then we'll find the adjacent side. We know that theta is 30 degrees. We also know that the hypotenuse is 45 meters. We want to find the opposite side first. So if we remember our trigonometric ratios, the sine of an angle theta is equal to the opposite over the hypotenuse. That's why I chose sine, because I wanted to find the opposite, and I knew the other two sections. Now, I can rearrange this just like I rearrange my other physics equations, because I want to solve for the opposite. I don't want to solve for the sine of theta. I already have that. So let's multiply both sides by the hypotenuse. So I can find the opposite side by taking the sine of theta times the hypotenuse. Now I can just insert those numbers. I need the sine of 30 times 45. Now use your calculator to get that sine. Make sure that your calculator is set to degrees. If it's set to radians, you're not going to get the right answer. So be sure before you begin that you've got it set to degrees every time. So then I hit the sine of 30 times 45. And that gives me 22.5. So my opposite is 22.5. I haven't rounded this yet because I'm going to round later on in my problem. All right, so let's now find this, the adjacent side. And we're going to do this the same way, except this time we're going to use cosine, because the cosine of theta is equal to the adjacent over the hypotenuse. Okay, rearrange it in just the same way to get that the adjacent is equal to the cosine of theta times the hypotenuse. So let's find that one. Inserting our numbers, we've got the cosine of 30 times 45. So cosine 30 times 45 gives us 38.97. Let's round that to 40. Get my pen to work here. Okay, so our adjacent side of our triangle is 38.97, but we're going to round that to 40. So filling those in, we've got 40 here, and let's go ahead and round this one to 23. Okay, so we've got 40 meters on this side, 23 meters on this side. Now you can see that in order to find the bottom of the triangle, I'm going to have to add the 83 meters plus the 40 meters to get 123 meters for the bottom of my triangle, because I have to have this entire length right here. Okay? Now I have the sides of both of my triangles, and I can use Pythagorean theorem to find the magnitude of my resultant. So Pythagorean theorem is a squared plus b squared equals c squared. C squared is going to be my hypotenuse. So I've got 123 squared plus 23 squared equals c squared. So let's put that in. All right, I get 15,658, but that's c squared. I want c, so I have to take the square root of that. And I get 125. So the magnitude is 125 meters. That is the length of that vector. That is the magnitude of my displacement. Now let's find this angle theta right here to find the direction that this thing is going. Now how am I going to do that? I'm going to use trigonometry again. And I've got a multitude of things I could choose from. I could use my hypotenuse that I just found. I think this time I'm going to go ahead and use tangent since we haven't used that one. Tangent of theta is equal to the opposite over the adjacent. All right, so let's tangent of theta, because I don't know theta, that's what I'm trying to find, is equal to my opposite, which is 23, over 125, which was my adjacent. Well, let's put that in. 23 divided by 125. Okay, it gives me this decimal number of 0.184. Well, that doesn't look like any kind of degrees. What the heck is that? I've got tangent of theta is equal to 0.184. That's just telling me what that ratio is between those sides. I can treat tangent just like I do other portions of equations, and I can divide by the tangent. We call this the arctangent or the inverse tangent. And on your calculator, you should see a button that might look like this. That's dividing by the tangent, okay? Or you might have a button that looks like this. So what I'm going to do is I'm going to, on my TI-84, I press my second, and then I press tangent to get that arctangent, and then I put in that number, 1.184, and that gives me 10 degrees. Okay, so the resultant for this particular problem is the magnitude is 125 meters, and it's 10 degrees above the horizontal. And that is the answer for number 1 and how we get it. Okay, let's take a look at number 2. A novice pilot sets a plane's controls thinking the plane will fly at 2.5 times 10 to the second kilometers per hour. That's written in scientific notation. What is that in conventional notation? That would be 250 kilometers per hour to the north. If the wind blows at 75 kilometers per hour towards the southeast, what is the plane's resultant velocity? All right, first thing we do is we draw a picture of this. Graph paper is always helpful for these. You could draw it to scale, but I'm not going to do that here. So number 2, we've got 250 kilometers north. Come on, little pen. 250 kilometers north. Okay, so this is 250 kilometers per hour north. That's that vector. Now what they don't tell you is when they say something is going southeast like that, they're talking about directly in the middle of south and east. And so this angle that this vector is coming down at is 45 degrees. So this is a 45-degree angle, south and east. Okay, so this is 45. That's important because you're going to need that to find the sides. And then this vector is 75 kilometers per hour. There's our wind speed. So once again, we have to have a right triangle in order to find our resultant, which is this particular arrow right here. So we have to construct basically a box that's going to go around our resultant like this, and we're going to use some trigonometry to find those missing sides. Let's draw one up here so you can kind of see it as well. All right. We know that the hypotenuse of this smaller triangle here is 45. Let's find this side of this right here. All right, let's go ahead and find that one. Now, you can see that that's opposite of our 45 degrees. And so we know our hypotenuse. So we've got the sine, remember from the last one, sine of theta is going to be equal to the opposite over the hypotenuse. All right, so we can rearrange that and we can get that the opposite is equal to the sine of theta times the hypotenuse by multiplying both sides by the hypotenuse. The sine of 45 is equal to times 75. All right, so let's put that in. Sine of 45 times 75 is 53. Okay, so this little side right here on either side of this rectangle is going to be 53. Our opposite is 53. Right? So this is 53. Now, what about this side? We've got to find this side of this triangle. I know that this full length is 250, but I can find this side and subtract that from the 250, and that's going to give me what's left. All right, all the fun of geometry. All right, so now we're going to use the same idea, but we're going to use this 45-degree angle here. Okay, so we're going to find. We can also use the cosine and find this side, or we can use this same 45-degree angle and use sine on this side. Doesn't matter. Let's do cosine. Cosine theta is equal to the adjacent over the hypotenuse. Again, we can rearrange. The adjacent is going to be equal to the cosine of theta times the hypotenuse. All right, cosine of theta times hypotenuse, cosine of 45 times 75. So let's give that one a whirl. Cosine 45 times 75. And lo and behold, it's 53 again. think that has something to do with those special triangles and it being a 45-degree angle there. So the other one's a 45-degree angle, right? Okay, so 53 is our other side as well. So I can remove this 53. I can subtract that 53 from 250, and that's going to give me the length of this side. So 250 minus 53 equals 197. And now you can see that this side is 197 kilometers per hour. And this bottom part's 53. So now we've got our right angle here, and we can find our resultant, which is the hypotenuse of that triangle. We can find the hypotenuse by using good old Pythagorean theorem. A squared plus b squared equals c squared. So we've got 197 squared plus 53 squared equals 41,618, but that is not my answer because I want c squared, which means I have to take the square root of all that. And that gives me 204.00, so we're going to round that off to 204. Got two significant figures. We could round this to 200. All right, so we've got 204 kilometers per hour. That is the magnitude. Now we need to find the angle here. Let's find this angle. How far is he from north? Okay. So let's find that one. How are we going to find that angle theta? Well, we have all these sides again. We know that this side's got to be 197 as well. All right. So how are we going to find this angle? And this one's 53. Well, I've got all kinds of things I could choose, but let's do tangent. If we do tangent, that's going to be the opposite over the adjacent. The tangent of angle theta is equal to the opposite over the adjacent. So the tangent of my angle theta in this case is going to be equal to 53 divided by 197. So 53 divided by 197 gives me 0.269035. Well, remember that I can take that, let's round this off. I can find the arctangent of that to give me the theta in degrees. So divide by tangent, divide by the tangent. And that's going to tell me, remember this is this key. And on my calculator, I hit second, then I hit tangent. And then I put that amount in. And I get a theta of 15 degrees. Now let's think for a minute what that's saying. What it's saying is he's 15 degrees east of north. Okay, and the magnitude is 204 kilometers per hour. And you can see from our vector that it's shorter, and it is in that direction. So he is going slower, and he's veering off somewhat to the east because of this wind that's blowing on him. All right, on to number 3. On number 3, you're given the same question as number 2, but they're saying now the plane has slowed down to 1/2 the velocity of question 2. Well, in question 2, the velocity was 250 kilometers per hour. And so here we're going to take half of that. What's half of 250? Our plane's new velocity is 125, right? So for number 3, this time we've got a plane that's flying to the north, just like we had before. But now that velocity is 125 kilometers per hour. We still have a wind speed of 75 kilometers per hour in that southeasterly direction. All right, so we still have a 45-degree angle here, just like the last one. And our new resultant here is even shorter. All right, but we're going to do this problem exactly the same as number 2, only this time we have a different value for our 125. I mean, for our north velocity there. We have 125 instead of 250. So we're going to do the first part of this problem exactly the same as we did before. We're going to do the whole thing exactly the same as we did before. But we're going to make this rectangle around. We're going to have to find these sides of the triangle here so that we can solve this problem. All right, you'll notice that when we set this up, we've got exactly the same, sine is equal to opposite over hypotenuse, so we're going to rearrange and we're going to get opposite is equal to sine of 45 times our hypotenuse. And notice it's going to be exactly the same as it was before. Our opposite is going to be equal to 53. Our adjacent is going to be equal to 53, just like we had in the last problem. But what's changed is our northerly velocity, and so we're still going to do that the same way. We're going to take the 125 minus 53, but this is going to give us a significantly smaller side here. So we get a 72 kilometers per hour for this side of our triangle here. 72. So this one's 72, this one's 53. We use Pythagorean theorem again, a squared plus b squared equals c squared, to find the magnitude of the resultant. So we've got 72 squared plus 53 squared equals c squared. $7,993, but we have to take the square root of that. And gives us 89. So the magnitude of this resultant vector is only 89 kilometers per hour. Let's find this angle right here. Again, let's do tangent. Okay, the opposite is going to be 53 divided by 72. Okay, tangent of theta is equal to that. Then we have to take the inverse tangent, or the arc tangent. And that gives us a theta of 36 degrees. So now this plane is traveling at 89 kilometers per hour at a heading of 36 degrees east of north. Okay, let's look at number 4. A truck driver is attempting to deliver some furniture. First, he travels 8 kilometers east, then he turns around and travels 6 kilometers west, and finally he turns again and travels 12 kilometers east to his destination. Let's draw a picture of what's going on here. First of all, okay, first he travels 8 kilometers east. So 1, 2, 3, 4, 5, 6, 7, 8. That's where he goes first. Then he turns around and goes 3 kilometers west. 1, 2, 3. Finally, he turns again and travels 12 kilometers east to his destination. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you can see by me drawing these vector arrows this way that we can actually just count the units, but we could subtract and add and get it that way too. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 kilometers here, plus the 1, 2, 3, 4, 5 from before. So 14 kilometers is his displacement from this point where he began to where he ended up. All right, I'm jumping ahead of myself though on this one. Let's look at what they're asking us for. A says, what distance has the driver traveled? Well, the distance that he's traveled is actually which way he's gone in both directions. So we have 8 for this one, plus 3 here, plus 12 here. So that's going to be 15 plus 8, 23. So his total distance is 23 kilometers. That's what it'll say on the odometer of his truck. That's how far he's gone. B says, what is his total displacement? How far is he from where he started? Well, we can see by looking at these blocks here is 12, 13, 14, 15, 16, 17. He's 17 kilometers east of where he started. I have to give a direction. Okay, so there's number 4, significantly easier than the ones I gave you before. Okay, number 5. While following the directions on a treasure map, a pirate walks 45 meters north and then turns and walks 7.5 meters east. What straight line displacement could the pirate have taken to reach the treasure? Draw a picture. He walks 45 meters north. And then he walks 7.5 meters east. What straight line displacement could he have used? And you can see that your resultant is going to come up this way. How do you solve this one? Good old Pythagorean theorem. A squared plus b squared equals c squared. So we've got 45 squared plus 7.5 squared take the square root of your answer. Gives me a number that will round to 46. Okay, so this is 46 meters. That's the magnitude. What about my angle here? How am I going to find the angle? Let's put my 46 meters here. I'm going to find this angle theta. Again, we can use a number of different things, but let's use the ones that have been given to us instead of what we've calculated in case we made an error. We could get part of it right. So the tangent of theta is equal to the opposite, which is 7.5 over 45. Okay, and 7.5 divided by 45. Then take the arc tangent of that. Gives us 9.46 and some other decimals. Let's round that to 9.5 degrees east of north. And so the magnitude, he would need to walk 46 meters at 9.5 degrees east of north. Number 6. Emily passes a soccer ball 6 meters directly across the field to Kara. Kara then kicks the ball 14.5 meters directly down the field to Louisa. What is the total displacement of the ball as it travels between Emily and Louisa? Okay, Emily passes her soccer ball 6 meters directly across the field. Okay, they're not giving you specific directions here, just to be purposely confusing, I believe. Okay, so if we're passing a ball directly across, let's say that's horizontal, so this is 6 meters. And then Kara kicks a ball down the field to Louisa. So we'll say it's going this way at 14.5. Mine are not to scale here. What's the total displacement? This would be the displacement vector. Again, just like our other ones, we're going to use Pythagorean theorem, and then we're going to use trigonometry. Same kind of deal. So we've got 6 squared plus 14.5 squared is going to give us our c squared, give us the magnitude of our vector. So 6 squared plus 14.5 squared, 246.25, but we have to take the square root of that. And that gives us 16 meters. All right, so the magnitude of this vector is 16 meters. Okay, let's find this angle theta here. My opposite, let's do tangent again. My opposite is the 14. My adjacent is 6. Okay, then I take the arctangent of that. (67.5). So my angle is going to be 68 degrees below the horizontal. Got to tell that direction. So magnitude of 16 meters, 68 degrees below the horizontal, or above the horizontal. They didn't tell us which direction was down the field, but we still have a direction here. Okay, last but not least, we've got number 7. Number 7, it's really important for you to draw a picture like it is with all of them, but this one in particular because it seems sort of confusing to what's going on until you draw it. You've got a hummingbird that's 3.4 meters above the ground. So what that's actually telling you is this is the origin right here. Flies for 1.2 meters in a straight horizontal fashion, and then it drops 1.4 to reach this point right here. So you can see that our resultant is here. We want to know how far that hummingbird is from where it started. All right, same as we've always done. A squared plus b squared equals c squared. All right, 1.2 squared plus 1.4 squared. 3.4, take this square root of 3.4, and that gives us 1.8 as a magnitude of that hummingbird's displacement. Now let's find how far it is below the horizontal. This is going to be our theta. Okay, so you can see that our opposite tangent, we use tangent again. The opposite is 1.4 meters divided by 1.2 meters. and that gives us 49 degrees below the horizontal. Okay, so the hummingbird's displacement is 1.8 meters at 49 degrees below the horizontal. Now, some of these, if you look at the answers that are given to you in the Connexus lesson, the degree amounts depend on where you're measuring it from. So if I said it was east of north, some of those answers are talking about north of east. And so keep some of your geometry in mind, that we know that right angles make 90 degrees. And so it kind of depends on what you're using. So it's very important that you don't just give the degrees, but tell me the degrees from where, okay? If I have to travel there, I have to know the exact directions on how to get there. Thank you very much. Hopefully this has been helpful, and I will put together a video for part 2. Bye.